Hi, Ms. Young here, and welcome back to Lesson 3. In this video, we're going to talk about the rational root theorem. You should have already watched the video on factor theorem and the remainder theorem. You want to make sure you have those down pat before we get into the rational root theorem. The rational root theorem is a way for us to find all the possible rational roots or real roots of a polynomial, and they need to be members of the set positive or negative p over q, where p is a factor of the constant, so your final term, and q is a factor of the leading coefficient. One way to help think about the rational root theorem is if you take the beginning part of rational, which is ratio. Ratio is a fraction, hence why we have p over q, and then we have root, so it's a ratio of the root. To help us find out these possible roots, we're going to use synthetic division. So here's our first example where we want to find all the possible roots for the polynomial. A starting point for this is to look at your constant term, which is negative 10 here, and determine all of the possible factors of 10. So I'm going to write them up here. So on the top, I want all the factors of 10. So this can be plus or minus 1, 2, 5, and 10. Now down below, we want all the possible factors of our leading coefficient, which here is 3. So that means our possible factors are 1 and 3. Essentially, we want to find all the possible ratio combinations taking one of these numerators and one of these denominators. So for example, we can have 1 over 1, we can have 1 over 3. And just continually listing those out. As you can see, we have a lot of possible answers, and depending on that constant term, we could and how many factors those have, we can have a lot of those factors. As we write these out, none of these are particularly divisible by 3, so none of these are going to repeat factors. As a starting point, as you get used to this, I would recommend that you start with all the whole numbers. So here, those whole numbers being 1, 2, 5, and 10. And you're just going to test those out with synthetic division. So here, we would do synthetic division. Oh, I grabbed the wrong thing there. You take all of your coefficients from your polynomial, put them in the top. Okay. And then you're going to test out one of your possible roots. So I'm just going to take 1, for example, here. So I'm going to put 1 there. I'm going to bring my 3 down. 1 times 3 is 3. 2 plus 3 is 5. 1 times 5 is 5. Negative 15 plus 5 is negative 10, and negative 1 times negative 10 is negative 10, and I end up with negative 20. So here, this did not work because we want this number to be 0. Now, to save some room here, save some time, I went ahead and tested all these roots out, and I know that negative 2/3 is going to work, so I'm going to show you how. Okay, so 3, 2, negative 15, and negative 10. And I know that negative 2/3 is going to work. So bring down this 3. Negative 2/3 times 3 is negative 2. That makes us 0, and this 0 as well. I get then negative 15. Negative 15 times negative 2/3 is going to be positive 10, and I get 0. So I know that this is one of the possible roots for the polynomial. Now that we have this bottom part here, as we do the synthetic division, all of these numbers down here will go down by 1 degree. I'm going to just clear this page here so we have some room. So we had at the bottom there 3, 0, negative 15. So I knew that negative 2/3 was going to work. Okay. Hold on, I'm getting ahead of myself. So Okay, so I'm going to rewrite these three numbers as our new part of our polynomial, one of the factors. So that would make this 3x squared, 0x, and then, which I don't need to write, and then minus 15. Okay, we can either do the synthetic division again here, or we can just factor. I'm here, this one right here is just going to be easier to factor. So I'm going to pull out a GCF of 3. So I have 3x squared minus 5. And now I can set that equal to 0 and find the remaining roots. So I have x squared equals 5. I can take the square root of both sides, and I get x is equal to plus or minus the square root of 5 here. And then you don't want to forget from our synthetic division that we found 2/3 also to be one of our solutions. Okay. Let's do another one here together. So again, we want to start off by coming up with a list of possible factors. So I'm going to list out our factors of 30. There's a lot here. So 1, 2, 3, 5, 6, 10, 15, and 30. Now the good news is that our leading coefficient is 1, and the only factors of 1 are 1. So we want to start off by, we're just going to test all of these out. Good news is that while doing the synthetic division myself, 2, which is one of the early ones in our list, does work. So I'm going to show you the synthetic division as to why. So our coefficients are 1, 1, negative 11, negative 5, and 30. So put a 2 over here, bring down this 1. 1 times 2 is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 11 plus 6 is negative 5. Negative 5 times 2 is negative 10. Negative 5 minus 10 is negative 15. And negative 15 times 2 is negative 30, making this 30 minus 30, which is 0. So 2 is one of our solutions. From here, we can rewrite this polynomial. So I end up with x cubed plus 3x squared minus 5x and minus 15. We can go through here and we can factor. It is really easy to factor by grouping here. We have some nice numbers. I can pull out an x squared over here and a negative 5 over here, leaving me on both sides with x plus 3 on the inside. Okay, so I have x squared minus 5 and x plus 3. Setting those both equal to 0 to find our final solutions, you would end up with x is equal to plus or minus the square root of 5. X is equal to negative 3, and you can't forget our 2 from up here, our 2. And we have 4 there, and this is a polynomial of degree 4, so I made sure I had enough. And there are our solutions. Here's a nice graphic here for whether or not it is factorable, or how to determine which, if you should factor, if we use rational root, synthetic division. So the goal is to find all the polynomials so that they're equal to 0. We talked about that in the last video. Okay, so 1 would be determine, is it factorable, yes or no? If it's yes, go ahead, use GCF X method, grouping, difference of squares, sum, difference of cubes, all that stuff that we talked about in Unit 0. If it is not factorable, but it is a quadratic, go ahead and throw it in the quadratic formula. And if it's not factorable, use the rational root theorem and synthetic division to help you find those roots. And you want to keep referring back to this flow chart here until you have found the same number of roots as it is for the degree of the polynomial, so your highest exponent. right, your next steps are to go ahead and practice. This will be a delta math. And then you want to complete your mastery check on lesson 3.